Let us look at two particles that are moving in such a manner that they collide. So let us say this particle 1 was moving with velocity m1, its mass is m1 and velocity was u1. So the momentum with which it is moving is m1 u1. And the particle 2 was moving with velocity v2 and it has a mass of m2. So its momentum is m2 u2. Let us assume that these two particles collide, meaning if u1 were greater, then in that case u1 is towards, like m1 is towards the left of m2, and if u2 were greater, then in that case m2 is towards the left of m1. So basically we are assuming that they do undergo collision, which is a one-dimensional collision. They are moving along the single straight line in one dimension. So after collision, without loss of generality, we can assume that the particle 1 has a momentum m1 v1 and the particle 2 has a momentum m2 v2. So the net overall momentum is definitely going to be conserved. So we can definitely write down the momentum conservation equation saying m1 u1 plus m2 u2 is going to be equal to m1 v1 plus m2 v2. So the net overall momentum definitely is going to be conserved. So this is one equation. Based on the law of conservation of momentum, there is no net external impulse or no net external force even in the horizontal direction. So whatever force of collision that they experience, they are experiencing that force within themselves, or that happens to be an internal force. So internal force is not going to change the momentum of the system. So net overall momentum of the system is going to remain conserved. So this is one equation definitely. But then again, we do not know whether the energy is going to be conserved or not. So basically, for the same purpose, or to rather state whether the energy will be conserved or not conserved, we define a coefficient of restitution small e, which is defined as negative of v2 minus v1 over u2 minus u1. So it is also called as relative velocity of separation upon relative velocity of approach. So this is how we define E to be. These two equations can be simultaneously solved to get the answer. So what is the meaning of E? We'll do the simultaneous solving in a moment. So what is the meaning of E? Let us understand this parameter E. Okay, this parameter, it is apparent that this parameter, if it can't be negative. So if this parameter E is between 0 and 1, then kinetic energy of the system is decreasing. If this is the case, then kinetic energy of the system is decreasing. So here kinetic energy decreases, not of one particular mass but of the entire system. Kinetic energy decreases. So if this parameter E happens to be equal to 1, then it can be proven that kinetic energy remains constant. If E equal to 1, then kinetic energy is constant. Or we can say Ke is conserved. And if this parameter E happens to be greater than 1, let us say E happens to be greater than 1, then in such a case, the kinetic energy of the system increases. Ke of the system increases. How can energy increase if somebody is wondering this? Then no, the overall energy of the system or the universe does not increase. Kinetic energy of the system increases. What does that mean? It only means that some other form of energy is converted into kinetic energy. Like for example, stored electrochemical energy or stored chemical energy or stored atomic energy, subnuclear energy is converted. This is just an example into kinetic energy. So basically, the first kind of collisions wherein E is between 0 and 1, these are called as inelastic collisions. And if E happens to be equal to 0, they are called as perfectly inelastic, wherein the two particles stick with each other because there is no relative velocity of separation. As we can see over here, the particles stick with each other. So E equal to 0 implies perfectly inelastic collision. So when E equal to 1, these type of collisions are called as elastic collisions. And when E is greater than 1, these type of collisions would be termed as superelastic collisions. So in elastic collision, it is easy to prove that kinetic energy is conserved. So let me show it to you quickly. So as long as elastic collisions are concerned, we are proving over here that kinetic energy is conserved in elastic collisions. So let us see how we go about doing that. Okay, so here in elastic collision, we know that E equal to 1. So we get 1 is equal to minus of V2 minus V1 upon U2 minus U1. So if you rearrange this equation, you will get U1 plus V1 is equal to U2 plus V2. Let us look at kinetic energy conservation. What does kinetic energy conservation look like? So if we are going to conserve the kinetic energy, we get half m1 u1 square plus half m2 u2 square is going to be equal to half m1 v1 square plus half m2 v2 square. So we are going to get m1 u1 square minus v1 square is equal to m2 v2 square minus u2 square. So by using the formula x square minus y square is equal to x plus y into x minus y, I get over here m1 u1 minus v1 into u1 plus v1. This is equal to m2 v2 minus u2 into u2 plus v2. But guess what? What's happening? It is the fact that using this momentum conservation equation that we have written above, m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2, what do we get using this equation? We get the fact that m1 u1 minus v1 happens to be equal to m2 v2 minus u2. So what are we saying? This particular term happens to be equal to this particular term. So what are we left with? Ultimately, we are left with u1 plus v1 is equal to u2 plus v2. So by back tracing this particular value, we can go back and obtain the expression that e equal to 1, or from e equal to 1. Okay, so we could start from here and go back to kinetic energy conservation as we came forward, and once we reach over here, then we can, so this is the same equation as this equation, then we can reach e equal to 1. So we could have started from e equal to 1, reached over here, then we could have multiplied with m1 into u1 minus v1 on one side and m2 into v2 minus u2 on another side. Then we could have written this step, then from this step we could have written this step, and we could have reached kinetic energy conservation. So kinetic energy conservation and e equal to 1 is one and the same. It is an if and only if condition. So if E is equal to 1, kinetic energy is conserved, and if E is not equal to 1, kinetic energy is not conserved. Currently we have shown this in case of only two body collision that is happening in one dimension. However, this can be easily shown or easily proven to be true in all the cases basically. So based upon whatever we have learnt till now, we can, so based upon these two equations, we can directly simultaneously solve the equations to get an answer for the value of v1 and v2, which we are treating as unknowns over here. We are treating that u1 and u2 are knowns, E is known, m1 m2 are known, and v1 and v2 are the only unknowns over here. So we can directly simultaneously solve these two equations and we can get the final result, which I am going to be mentioning over here now. Okay, so we get, after solving this equation 1 and equation 2 simultaneously, I get the result v1 is equal to m1 minus em2 upon m1 plus m2 into u1 plus m2 plus em2 upon m1 plus m2 into u2. Also, once we write down the expression for v1, it is very easy to write the expression for v2. The expression for v2 is going to be written down by replacing the terms with subscript 1 by the terms with subscript 2. So it is m1 minus em2. Here we'll write m2 minus em1 upon m1 plus m2 remains the same because m1 plus m2 is the same as m2 plus m1. So this into, here we have u1, so instead of that you will write over here u2 plus, here we'll write m1 plus em1 upon m1 plus m2. Instead of u2 you will write over here u1. So these are the two answers, out of which only one needs to be remembered. So one needs to be remembered properly so that directly the other expression can be written down. Sometimes Some people may also adopt to just understand momentum conservation and the equation of E happens to be called as the coefficient of restitution. So there is a terminology for E, it is called as coefficient of restitution. So this is, so some people may want to solve equation 1 and 2 simultaneously always instead of using the direct result. So to each his own preference essentially. So this is the basic understanding of one-dimensional collision, wherein two particles are colliding, and this is the before collision situation and this is the after collision situation.